Hi, my name is Julia Silgi and I'm a data scientist and software engineer at our studio. And today in this screencast, we are going to talk about giant pumpkins. It's a pumpkin time of year here when I am recording this, and we are going to predict the weight of pumpkins in these pumpkin growing competitions that we have data for, using other characteristics about the pumpkins. This screencast is a good one if you want to get started with using workflow sets in tidymodels. This is this concept we have in tidymodels to be able to fluently fit and explore multiple combinations of preprocessors and model estimators at the same time. So let's get started.
All right, it's getting to be a pumpkin-y time of year, and it is time to train a model and learn something about some giant pumpkins. I don't personally have a lot of experience with competitive pumpkin growing, so I think this will be interesting to learn a little bit about it. So, a lot of this reads directly in as character when I really want to try to coerce some of these things into numeric, because I want to be able to build a model and do do some of the kind of these things. Also, this year, if you look at the data dictionary for this ID is a combination of the year and the type of thing that it is. Like whether it's there's different like species of these kinds of pumpkins. So let's start with that. And we can use separate from tidyr. And first we'll say, what do we want to separate? And then what do we want to go into? So let's separate into the year. And, we can call that species or type. I'll call it type here. And so now notice that that thing that had the year and the type is now separated into two things. And let's see, I looked this up ahead of time. And so there are all these different kinds of pumpkins, like field pumpkin, giant pumpkin, et cetera, et cetera. And so let's just choose, if we're going to build a model, I'm just going to choose one of these different kinds of varieties or species. I actually don't know if it's variety or species. I don't know. I don't know much about pumpkins and how they work, but let's pick the giant pumpkin. So let's only keep the ones that are giant pumpkins. That's still a lot there. And then let's start thinking about some of those other columns that we have. So weight. Wow, those are some big pumpkins there. 2,000 pounds of pumpkin. So there's the weight here, and then this is like another estimated weight there. Let's use this one. And there's several here things like year, weight. This is the over the top measurement. Like if you take a measuring tape and measure over the top of the pumpkin in a certain, very specified way that they use in the competition. So let's use mutate. Let's use mutate across here, and then the specific columns that we want to do, what we're going to do is we're going to say use parse number so that we can change those from right now they're all as a bunch of these are characters, and we actually want them to be numbers. So the ones that we want to do this for a year, weight in pounds, that over the top measurement, and what else should we throw in there? How about place? Place also is currently a character. A bunch of these are characters, but they probably have entries in them that are not numbers, but those will, coerce to, they'll convert to NA, and we just won't keep those. So that will be okay. So let's do this. And you can see that this did in fact happen. Like we were expecting a number, and we actually had this, so it turned it to NA there, but that's okay. That's what we were expecting to happen. And then let's select, what do we want to use here? So the thing that we are going to predict here is the weight. We're going to try to predict the weight of a pumpkin from that over the top measurement, which I'm sure, like that has got to be super important. Let's do year, and, we'll be able to see, like, are pumpkins getting heavier over time? Are we getting bigger pumpkins? Made place. I mean, obviously that's just like another measurement of, um, it's like that's the place in the competition, like first place, second place, third place. But that might be interesting for visualization. Maybe that GPC site, that is where the competition happened, where this competitive pumpkin weighing happens. And then I don't know, country, maybe we'll see if, so that's the country where it was grown, which I think doesn't have to be necessarily where you take your pumpkin to a competition. So let's look at these other things, like, I don't know, city and state, those are going to have too many levels. And grower name, I don't think I'm going to work with that, I don't think. And I'm not going to try to deal with, like, the other estimates of weight and that type of thing. And there's a lot of missing data, I think, in some of those other things. So this is what we're going to stick with right here. So let's call this pumpkins. There we go. All right, so this is still a lot of data, which is going to be great. This is going to be really good. Let's start out with a little bit of exploratory visualization before we pop into the modeling. So let's put the over-the-top measurement of the pumpkin on the x-axis and the weight on the y-axis. So, I expect this to be very strongly related. Like a bigger pumpkin is going to be heavier, right? And this just has got to be very strong relationship. If it's not, we're in big trouble. Okay. All right. So this is actually very useful, because this is probably showing us that there's some bad data in here, some data that's not very good. So we're going to be able to clean up our data a little bit here by you doing this exploratory visualization. So what if we say, let's clean up those really high over the top measurements, which I think are wrong. Like, they're like in the like something's wrong with those. And then the low ones too, that looks like something is wrong with those. So I don't know, 10? Is that right? Whoops, that's not a pipe. Let's try that. That looks less, greater than, yeah, that looks pretty good, right? And so we can change, let's see, so let's make this more clear. Over the top inches. And that's weight in pounds. Nice. And while we're here, I mean, we would, so this is, you look how strong this relationship is, right? Like, this is just geometry. Like, this curve shape that we're seeing here, this is, this is just like, just math here, just like physics, how space works, right? Like, so this is no big shocker, right? But this kind of very strong relationship that we see here, we can use in a model. And it's not perfect, right? Like, we do see some scatter around this relationship. And so when we add other features to our model, we'll see, can they explain any, like, this will be the main thing that drives our model. And then we'll be able to see, can any of our other features we have explain any of that variation around that? It might be interesting to see the place, like the place that these pumpkins get in their competition. How does that vary along this plot? That's pretty nice. That's pretty, actually. I really like that. So these are the pumpkins that place really highly, right? These enormous, over a ton weighing pumpkins. And then down here we have these, like, lower placing pumpkins down here. And we see this nice, pretty gradient. Pretty nice. I like that. Let's make a couple of other exploratory visualizations before we get going with the modeling. Let's do something very similar here, but so let's take out this. Let's just make the points, gray or something boring. And then let's put a smoother on here. And how shall we do this? Let's make the color is factor of year, and then I think I'll need to change this to from continuous to discrete. All right, so it used GAMs, which are super wiggly. You see how wiggly it is. That's so funny. Okay, so let's turn off the. It'll be easier for us to see here if we turn off the error bars on that. And if we want to kind of exert some control over those, is that right? Yes, some control over these smoother lines that we have, and we could say color equals null. We can come in here and we can like really be very explicit about how we want to make that line go. So for example, if we say method equals LM, you probably have done something like this. You know what that will do. That just makes straight lines, which we don't want it to be a straight line, but we maybe don't want it as wiggly as that GAM was. So we can give it a formula, and so we can use Splines, our friend Splines. So I think how does this work? Let me remind myself. So, yeah, it works like this. It works like this. So I think, is there an example here with splines? Yeah. So let's just do it like this. And three is probably about right. 3 is probably about right. That's still pretty wiggly. Splines. What if I cut a few more out there? Yeah. All right. I'm maybe forcing this a little more than I need to, but basically I've made it, I've exerted some control over how this curve is fitting here. I guess I could like make it, I could go to the actual that I know it's like what the actual power is. But anyway, this is good. So here are the years, right? And it's like, well, do I think maybe we're getting to like some kind of steeper relationship, or heavier, like bigger pumpkins in more recent years? I don't know. Maybe. Let's make one more exploratory plot before we go on. Actually, it'll be totally different. Let's just start over here. Let's look at country. How many countries are in this? Who makes the biggest pumpkins? Let's see how many countries we have. Okay, so there's 30 countries. That's too many to put in a plot. So let's use fact lump. So it has different ways of lumping factor levels together. Let's lump them and say we only want to keep 10. So it's going to put everything else other than the top 10 together in an other category. And then yeah, let's do that. That'll be good. And now let's pipe this into a plot. Let's put country on the x-axis, the weight in pounds on the y-axis. Let's say color equals country. And then let us make a box plot like that. All right, let us remove theme, legend, position equals none. And then let's right now they're in alphabetical order, and let's not, instead of putting them in alphabetical order, let's put them in the order of I think this would do it. It's either the mean or the median there, like that. Pretty good. That's looking pretty good. Let's say I think most people can tell those are countries, so let's take that label away. And let's say weight pounds. Whoops, I need the plus there. That's looking pretty good. Now, in a situation like this, often it is nice to actually see the data itself. This is kind of a lot. So this is borderline where it's useful to put the data on or not. But let's I think the way I can get rid of these, so if I say outlier color equals NA, that gets rid of the outliers. And now I can actually, on top of those box plots, I can actually plot the data itself. I'll use geom jitter for that. And I will say, I'm going to have to pump the alpha way down. And I don't know, the width, make it like 0.2 or something like that. Let's actually make it even less. Like that. All right, I think I like that pretty well. And so you can see here that the pumpkins in Belgium are enormous. I mean, just enormous. And that you can tell, from this plot, now that we've plotted both the box plots and the data, that the most of this data set is pumpkins in the United States, and Japan and the UK have the smallest pumpkins. So, so we'll see if including these in our model helps the model predict better. Like, does this country level information help explain any more of the weight of a pumpkin? And, does it help and at all relative to just looking at that over the top measurement there? All right, so let's get started. So I'm sure there's so much more that we could do for exploratory visualization here, but let's call that enough for now. And let's get started with some modeling. So let's load tidymodels. And let's first spend our data budget, set up our data budget here. So I am going to take the pumpkins. I am going to do this. I'm going to do the same filtering. So basically this is cleaning. This is what I believe to be not good measurements for over the top inches. And then I'm going to pipe that to initial split. I'm going to use stratified splitting. Stratification basically never hurts you, and it can often help you. So I'll stratify by the distribution of the weight in pounds. And then I can, so this will give me a split object, and then I will take the training data from the split, and I will make pumpkin test. I will make testing data from the split like this. And then let's make some resamples. So I'm going to set the seed again. And I am going to make v-fold cross-validation folds, resampling folds from the training data. And I'm going to do it stratified again like this. And I'll say pumpkin folds like this. So think of this part looks very similar anytime you build a model. You take your data, you split into testing and training, you create resampling folds. This is spending your data budget. So you have a certain amount of data, you have to decide what are you going to use for training data, what are you going to use for testing data. Once you have your training data, how are you going to create resampling folds to be able to choose models, compare models, tune models. And all right, so now let's, like I said in the intro, now let's talk about making a workflow set. So this is a good video for anyone who is just thinking about, hey, I want to think about how to use a workflow set and what it is. So this is going to be a pretty straightforward workflow set. So what a workflow set does is it allows us to combine different preprocessors and models, and then all at once fit them or tune them and see what our results are. So let's start with a base recipe here. So a recipe is what we use for preprocessing or feature engineering. And let me remind myself what's in the training data. So we're going to predict the weight in pounds by, pretty obviously that over the top measurement in inches, plus let's see if year is important, country, and let's see if this site where the competition is, if that's important. And then we send in our training data. The reason we send in our training data to a feature engineering recipe is so that the recipe can learn what columns are there, what their data types are, all that type of thing. And for our base recipe, let's say one that we might use with a tree-based model, all this stuff is pretty much fine, except that these have too many levels. Like, how many levels does GP? Like, that's way too many. Look, way too many. But most of the pumpkins were at just, like a couple of these sites are much more common than the rest of them. So let's we don't need to keep all of them in the data set here. So let's use step other. So what step other does is it collapses down uncommonly used factor levels. So let's do it for country and for GPC site. I feel like the threshold is too high. Yeah, let's drop that threshold like that. So let's, whoops, not county, but country. And so if you want to, we're not going to do this when we actually fit, but if you want to check and make sure that's working, we can prep it. And if you want to see, well, what does the data look like when it comes out, we can say bake. And then if we just say bake new data equals null, that just gets back out the pre-process training data. And now look, it says like other here. It will do the same on country. All right, so we've got our base recipe. Now let's say, okay, what if we want to use a model that needs all of its inputs to be numeric? Let's say we wanted to use a MARS model, a multivariate adaptive regression splines model. So like splines are pretty, when I saw that shape of that, I'm like, of the, the relationship between over the top inches and the weight, I think, well, splines will be a nice flexible thing to be able to use for that. So this is probably going to work pretty well. So if you look at in the documentation, what do we need to do here? We have to convert any factor predictors to numeric values. So let's set up a recipe for that. So if we take the base recipe and we add step dummy all nominal predictors like that. So let's call that indicator recipe. So this is one that takes the base recipe and then adds on indicator variables. And then let's say what if I just want to use a linear model, but I want to, in the feature engineering, put the splines. So let's say we then take the indicator variable recipe and we're going to make step B splines. We'll make B splines here, and let's say we want to make B splines for that, for the over the top inches. So let's call that spline recipe, like that. So there's a bunch of recipes. I've got a bunch of recipes ready. Now let's make a bunch of models. So let's do a tree-based model. Let's do a random forest model. I'll say random forest spec. A random forest. Let's just set trees to a high value. So we don't need to tune it really then. We'll say set mode equals to regression because we're predicting this this weight in pounds here. And we'll just use the default engine, which is Ranger here. So that's there's a tree. So there's a tree-based model. Next, let's use that Mars model. So let's say Mars spec. So this is that Mars I'm going to say it wrong. Multivariate adaptive regression splines. Let's just use the defaults there. I think that probably is fine for at least a comparison. And same mode And we're just gonna use the default here of Earth. It's actually the only option, so I guess we actually don't have to put it there, but there you go. And for the linear, then let's do a linear model. And we're just gonna use linear, I cannot spell, linear reg, like that. And I could do the same thing for completeness, but the defaults are all in there, so I don't have to do that. I can make it shorter like this. There we go. Okay, so now I have 3 recipes, 3 models, and now it's time for me to combine them in a workflow set. So a workflow set like this combines a list of preprocessors with a list of models and then lets you handle them all together. So let's put our three preprocessors in here, a base recipe, the base recipe, the indicator recipe, and the spline recipe. And then let's put our 3 models, our F spec, Mars spec, LM spec, like this. And the default is to say cross equals true, and that means you do like a cross join, and you make like you join them all together so that the base recipe goes with all 3, the spline recipe goes with all 3. In this case, we don't want that because the base recipe is meant to go with the tree-based model. The indicator recipe is meant to go with the Mars model. The spline recipe is meant to go with the linear model, so we do not want to cross them. The default is to cross them and make them all go together, but we're going to set cross equals false. Maybe this will look nicer. Yeah, that looks better. Let's call this my pumpkin set. My pumpkin set, like so. And let's look at what that looks like. All right, so recipe 1, 2, 3, random forest Mars linear reg. So this is now a workflow set, and I can now handle this. So what I'm going to do is I'm going to set up parallel processing here on my computer. I'm going to set a seed. And then I am going to use workflow map. I'm going to map across my pumpkin set with a function. I can actually just use fit resamples because none of these need to be tuned. I'm just kind of using some sensible defaults for all 3 of these models. And then what I'm going to evaluate them on is the my resamples, like this, pumpkin folds. So if I say pumpkin result like that, maybe it would be nicer if I did this. Okay, and now what's going to happen is I'm going to get this started. So now what's happening is, so I have 10 resamples for a pretty big data set, and for each of these 3, so there's 3 combinations of preprocessor and model, and it's going through, and it's fitting these 3 models 10 times each. So it just fit 30 models in that time that we just had. And then I've got these results here, these resampling results. So that went pretty fast, which is nice. Okay, so now it's time for me to evaluate that. So you can always, I can go and do lots of things, by hand and get in here to get these results out, but we have a few convenience functions to get the to be able to look at this conveniently. So if I want to, I can use auto plot onto the pumpkin results, and this is pretty interesting. This is pretty interesting. Okay, so RMSE, remember, lower is better. R squared, higher is better, and so RMSE is in the units of the original, the outcome. So this is in units of pounds, and R squared, like 1 is good and 0 is bad. So if you look at this, the spread is bigger for the linear model with splines, but these are all about the same. Like we're not seeing that much difference between a random forest and a linear model. In fact, like, we see significant overlap here. So it's like, and if anything, the random forest model is worse, right? Like, but we don't see strong evidence for that. So the linear model with splines is probably the best choice here because it's going to be faster to fit, more interpretable. The Mars model is kind of in between, both in terms of interpretability and how fast it is to fit. But again, it is worse, or I mean, it's about the same, maybe worse than the linear model. So that is a pretty interesting result here. And like the reason why is probably because from those first plots we looked at that relationship is so strong between the over the top. Well, I guess we don't know that yet. Let's look at the results and let's see. So okay, so here are the metrics, and we can look at the things we just saw visually in the plot. Now we can look at them in a table. Here we see, so here are the RMSE values. Here are the R squared values. These are all basic. These are like so close to being the same. So we would choose, in this situation, I would choose the simpler model. Okay, so how do we get it out? How do I get it out of there? Like, I put it in there, but how do I get it out? Here we go. So we can use, there's a whole family of extract functions. Whoops. Extract. Here we go. Okay, so there's this whole set of functions that like if you want to pull components out of other objects, we can use these extract functions. So if you're ever looking at a tidymodels object and you think, how do I get that thing out? You want to look for the extract function. So if I call extract workflow on pumpkin result, if I do it with no argument, it's like, well, which one do you want? And so then I can put in the ID for the one that I want. So this is the one that I want here. So here is the workflow that I want. This is an unfitted workflow because when I did all this resampling, it fitted 10 times to the 10 resamples, evaluating on the assessment set of each one of those resamples, and it threw all those models away. I don't have any of those models anymore because the purpose of those fits were just for estimating performance. So I need to fit this again to the whole training set. During this process, this model was never fit to the whole training set. So let's do that. Let's fit to pumpkin train like this. So let's call this final fit, like so. So now this is an object that I can predict with. So for example, I can say predict final fit on my test data, which I have not, looked at so far. So we've got a little warning about the splines that's like, hey, what are you doing with my curvy splines? But, so that's good to know there. So I can predict on it. What I also can do is I can tidy it like so. So if I tidy it, I see all the predictors that went into it. So here are all the predictors. So if I arrange by the estimate here, so here are the big things that affect the weight a lot, and then I go down here to the things that just affect the weight a teeny tiny bit. So look how enormous the spline terms are. These are the spline terms. Just enormous, huge. The effect, like the enormous effect here is from the spline terms. The net like this one is 10 times smaller of like the site. Like is it at the giant pumpkin growers competition? And then is it a United States pumpkin was it at Stillwater Harvest Fest? And then here, Germany goes in the other direction. Germany makes it a smaller pumpkin. It's a negative sign. And year is positive, and actually the p-value is quite small. So it looks like we do see evidence here that pumpkins are getting bigger, but the effect size is super tiny, super, super, super tiny. I mean, that's one of the lovely things about linear models is we just get to see all this and do, I guess, some inference here a bit. And so when we had these more complicated models, they're learning the same kind of relationships and predicting via these same kind of underlying relationships. We don't get, of course, this like same kind of really straightforward output that we have here. This is a really nice example of being able to have just like a really huge a relationship that dominates something, and then like, are we able to measure any other anything else that kind of is on top of that? And of course, some of these are the p-values of some of these are big.
All right, so we predicted the weights of these giant pumpkins from the other information. The most important predictor was, as makes sense, the measurement that we have is a measurement of the size of the pumpkin, and then we were able to see what are the other things that we know about these pumpkins that also have an impact on their weight, like the year, it turns out, and the country and things like that. We used workflowsets to do this. Workflowsets are a good option to know how to handle if you are in a situation where you want to try out different feature engineering approaches, different model approaches, and different combinations of them, and you want to be able to fluently use them all at once and tune them, or in the case like we did here today, fit resamples. If you're watching this video, like the week that I am posting it, then I encourage you to take this year's tidymodels survey, the survey where we want to gather feedback on what those of you who are using tidymodels think would be most important for us to concentrate on for 2022. So look for that link in my blog post. I hope this was helpful, and I'll see you next time.